And we're back. Hey, everyone. Hey, Andy.
Hey.
Glad to see you made it back after that grueling session on resource files and tilting.
Yeah. Tilting, yes. If you see me tilt effect, it's me falling asleep.
That's what it is. Okay, excellent. That's what we know. That's what we'll say. So now we're going to dive into what you've all been waiting for, files and storage. So that's like taking things offline on your mobile stuff. So here is where we are today. We are almost at that coveted meal break time there, 60 minutes. I know you've all been waiting. I know you've been waiting for us to eat. I know you haven't been munching when watching at the same time. So files and storage on phone 8. Let's just dive into that. Oh, but before we have to do that, we got to see what's on day 2. All right, enough of that. You've seen that so much. Okay, so let's look at the agenda. What do we have today? In 7.1, we have isolated storage and the APIs that we've been working with for the last couple of years to do that. And with local storage and isolated storage is something we'll kind of compare and talk about. We're going to talk about the new Windows storage programming via the Windows Phone runtime. We're going to talk about some special folders that you may not have heard about. And then we're going to talking about looking at those removable SD cards that Andy talked about earlier in the day. So let's move right along. Oh, but of course we have to say what we're not going to talk about, just so that you don't get confused. So we're not going to do a session on the local database, also known as SQL CE or SQL Server Compact, or SQL Everywhere. No, it's not called that. Yeah. No, we'll get a lawsuit from somebody there. But luckily, if you saw Andy and Rob, the other Rob, the better one, last year.
The taller one.
Yes. Talks about cheese more than I have. Plenty of links for Channel 9 videos to see everything you ever wanted to see about using that.
So the deal is we couldn't cover everything. Much as we'd love to make this an exhaustive course for people who are new, everything that was taught last year is still valid. So it hasn't expanded, but it's still totally supported. And so the videos we did last year are still totally valid for that. So if you want to check that out, you can get it from those links that you saw on the slide there. So channel9.mst and Mango Jumpstart. So we're just going to concentrate on the newer stuff.
Let's talk about the new stuff. All right, let's get these slides going here. Oh, and the last thing here, you see SQLite database, native only. So over the summertime, we made an announcement that we were going to support SQLite both on big Windows 8 and Phone 8 to give you more flexibility in your storage options. Lots of people love SQLite. It's a popular open source embedded database. So right now, at the moment, I think you can only access that via C++. But I think I'm hearing rumors that somebody's working on something to wrap that to make it accessible to manage code.
Yeah, we'll wait and see what comes out on that. But
absolutely. But I know you can already do it. I've done it on big Windows 8. And so anyway, stay tuned. So let's dive into persistent storage in Windows Phone 8. So when we talk about local data storage, I think the big takeaway on this slide is you have two separate locations on the phone where things are stored. There's the installation folder, where your application kind of gets exploded out onto the device. This used to be known as the app data folder on phone 7. But anyway, all the content, read-only things, part of your app that were pre-configured, and you could send a database down and things like that. And then secondly, there's the local folder. And so this is where you can do some read-write stuff. And this is formerly known as isolated storage.
That's what we used to call it.
That's what we used to call it.
So the isolated storage, you can still call it that, but you'll hear more and more going forward, people will talk about the local folder, which is what people call it on Windows 8, spookily enough.
Yes.
Yeah.
So we better stay in line with those guys.
Yeah. Oh, yeah.
Yeah. So anyway, two places. One's read-only, one's read-write. Read-write's probably going to where you'll be spending most of your time doing interesting things. All right, so look at this. We have a smorgasbord of different ways to address these different storage locations. We'll dive into each one more individually, a little more in depth, though. But we talked about we're not going to dive in too much into the local database, and then we have file access, how you may be accustomed to doing it, going after the isolated storage files. And then we also have a new way of doing things using the Windows.storage API via URIs. So lots of forward slashes and things like that everywhere to open things. URIs, very webby. but important. And then there's other ways to do it with a storage API, where you can just do it here at the bottom level, where you can see it doing windows.storage and code that may seem familiar to you. I think the takeaway here is you have a lot of flexibility.
Yeah, there's lots of different ways of doing stuff, and this is kind of a quick reference lookup for you, because it can get kind of confusing.
Certainly, certainly. We don't want you to be confused. All right, so let's talk about all these alternatives. 3 ways to reference the same file. So there's the old school, but currently still relevant, isolated storage way to get to that same file, get user store for application, to get a reference to a particular file and to open it. Then there's the new URI-friendly Windows 8 style of working with storage file to open that. And then there's some storage APIs that maybe look a lot more similar to how you worked with isolated storage, where you access that local folder to get it currently and then to open those files. One thing that we'll be talking more and more about is how everything gets much more asynchronous than previously. Even though Silverlight, we've always talked about Silverlight being asynchronous everywhere, you had no idea how much more asynchronous we can get. So let's kind of take a quick look at how we would store data using the Phone 7 isolated storage APIs, which again you can continue to use today. So there's a systemio.isolated storage namespace. So the isolated storage file is a file in that storage area, or rather just a storage area that you're going to address. It contains files and directories. There's a file stream that you'll get a reference to work with those. And then we also have this isolated storage settings, which is a nice, easy to use name value pair dictionary, which is good for part of your project lifecycle, your application, for saving some quick values. And so here's a quick, easy way of how we would go about saving data using isolated storage. So we get reference to isolated storage file object, calling the static get user store for application method. And then we use the isolated storage file stream to create the file, in this case milefile.store. And of course we're good programmers, so we're using to make sure we clean up our resources, get things closed.
Yeah, so using disposes of things once it goes out of scope. Yeah,
absolutely. So you don't have to worry about it disposing yourself. And then the all too familiar stream writer, and then you'll pass in that isolated storage file stream into that, and then you can start writing to that file. So it's pretty simple stuff, just writing to a file and then closing it. We just put a string in there. Well, you can't write without reading, right? Well, maybe you could. So now, how do we do the reverse? So we want to load the data. I think the takeaway, and I think you're going to see this over and over again in some of the samples here, is how similar it looks, both going, saving data and reloading it. So again, with isolated storage, you're still going to do the same thing. You'll do the using for the isolated storage file. Then we'll do good defensive programming and test to see if this file exists first before trying to do anything with it. And then once we've seen that in fact is there, then we'll open the file. And then we use the stream reader and read the text right out of it. So pretty simple stuff there. So are we going to do a demo here, Andy?
No, actually, what we'll do is we'll pick it up when we get to the next one.
I think
we
that's
do a nice compare and contrast.
I think that's a good idea.
Yeah, let's do that.
I think that's a good idea.
Yeah.
All right. So application settings. I kind of alluded to a dictionary of name value pairs where you can save things, properties, things related to your application that you need to save as part of its life cycle. And we make it really simple using these isolated storage settings methods to do that. You just set the indexer, application settings name, whatever you want to call it, and set it to the value. And then since that's all running in memory, you need to make sure you call the save method so that it persists it to storage. And then on the flip side, to load those settings, first thing you need to do, kind of back to defensive programming, check to see that the name that you're actually looking for to get its value actually exists in the dictionary. And then if you verified that it does, then you return it. Make sure you put a cast in front of it if it's a string or an int or whatever. And then, anyway, pretty simple stuff. Reading and writing to a dictionary, populating values in your application. So we've seen how we've been doing it for the last couple of years. Now let's move ahead and see how you might do the same things using Windows Phone runtime storage, which is similar to what we have on big Windows. So we have these new Windows storage classes, to work with that same stuff, and so you have the storage folder, which is like our isolated storage, your area with files and dictionary, and then you have the storage file itself that you're actually going to work with. The one thing you do not have, though, this time around is you're not going to have that local settings to do that quick name-value pairs, save a color, save a name, things like that. So you'll have to come up with there's plenty of easy ways for you to do that yourself, but you just don't get it by default using the new libraries that we have with Phone 8. So let's take a quick example of using storage folder to save the data. So we've got the namespace, we're using Windows storage, and then we're going to save to a local folder. And all this happens asynchronously now. And so as Andy always reminds me, any code that you have in there, if you created a function, a method where you have an asynchronous and you have an await, you also need to make sure that in your signature, the part of before you have your return value, that you mark it as async.
Yep. Well, in fact, the compiler will force it on you. Yeah.
Oh, excellent.
Yeah. So yeah, I'm conscious that we would love to sort of go into async and await as a separate topic because it's kind of interesting, but we haven't got time, frankly.
Right.
So
yeah.
There's a bunch of resources on the web, and I will be blogging about it as a sort of a JumpStart Extra topic.
A JumpStart Extra.
A JumpStart Extra. There you go.
Yes.
Yeah.
JumpStart Extra.
But yeah, so unfortunately we can't cover that. But essentially, yeah, it's any API that has the potential to take, I think it was 75 milliseconds. Anyway, anything that potentially takes a long time. So we're talking about I/O operations essentially. Now use this new async calling method, which means that you can make the call to this async method. It will go off and do its stuff, and it kind of calls home when it's done, and you don't block the calling thread anymore. So it's a really lovely technology, and it's fun to work with. But it is kind of new, so you will find throughout the Windows Phone runtime a lot of task-based, because that's what we're talking about, async, awaitable method calls.
Excellent.
So I'll follow up on blog, but
that's good to hear.
Yeah, there's plenty of stuff on the web about this.
All right. So back to our slides here. The simple example. So this time around, we're just going to get a reference to applicationdata.current local folder. So that's kind of like what you did with isolated storage. And then we have the storage file. We want to create the file like we did before, but since it's an async method call, we're going to put that await in front. And then you have this one extra parameter, this argument in here, where you get to have this enumeration, create collision option. And so this is handy. And so you can say open if exists, and rather than blowing it away or however you might do it. And then you're just going to open that file, again, using another async method, and then use the stream writer to take care of that data, to save that data. Lots of async stuff everywhere. I'm really looking forward to Andy's blog post because this is all so new to so many people.
Yeah.
It really is. It really is. And then the reverse. How am I going to get the stuff out? So again, get that local folder reference. I'm going to get reference to the actual file. I'm going to read it in. I'm going to use a stream reader, and then just pull it into the string. So pretty simple stuff. So hopefully that's your takeaway here. Just for saving simple things, it's really, really simple, real easy to work with. But of course, there's also the URI way of doing things with the MS app data, whack, 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 local.
Yeah. Lots
of that fun stuff. And there's some...
That local is important, actually. Yeah, if you're going for the local folder, it's always got to be ms-app data, kind of whack, 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 local whack, yeah.
Exactly.
Why?
Well, I don't know.
It just is. That's what it is.
So, Andy, something struck me strange about this when I first looked at it. We're putting a try-catch around there as we're trying to open this folder here, this file. Yeah. We're using this, and you're testing if
yes, I know what you're going to say.
You know what I'm going to say. It seems like I'm controlling the flow of my application using exception handling.
Ah, gosh, and that was... It wasn't that on day 2 of kindergarten. They said, don't use exceptions.
You were in the same place. We were in the same kindergarten class, and they were telling us never to do that. But it looks
apparently there are exceptions.
Yes. Exceptions. So that you didn't even know.
I didn't even know I was doing that. No.
Well, he's that good, folks. He's that good. So if you can't get a handle on it and you throw an exception, then you'll know.
Yeah.
And so anyway, you're actually going to control flow via exception here potentially. So little heads up on that. So unlearn some of those things. In this case, just an exception to that rule. So compatibility, and part of what we're talking about is compatibility. We want you to start learning how to write code that you can, move back and forth between, our neat new tablets and things like that. It's definitely a subset what we have on Windows Phone 8 compared to WinRT. We talked about the part that seems a lot like isolated storage. Things that you don't get though. So if anyone who's taken a class or learned about doing some development for store apps on Windows 8, there's a lot of, the cloud is doing a lot of nice things for you. And so part of the roaming data, where you're working and you can kind of pick up where you left off somewhere else, temporary data, things like that, and those settings, you do not have those in the phone. So don't try to use them because they're just not going to work. You have to come up with another way of doing it. Andy, this is an interesting one here. This thing, putting it right into the XAML, this image tag, using the ms-apex.
Right. Yep. So yeah, that's the top one is the Windows 8 usage, ms-apex, and you would expect, seeing as how we support ms-apex on Windows Phone, that you could do the same thing. So this is just calling out a weird difference, if you like. So all you have to do is, instead of passing a new URI using ms-apex on the phone, there is a difference here. This is one of those things where we've got a bit of an incompatibility.
Okay.
So it's just to call that one out.
All right.
Yeah. Can I do a demo?
Let's do a demo.
All right. Let's do a demo.
Excellent.
Okay. So I'm going to run the demo on here. So I've got. I don't want this one version. Let's open the right solution. That might be a good start.
Yes. The right solution is always the right start.
What? Am I not making sense anymore?
No, you are.
Okay. Did I ever make sense? Right.
Yeah, so it works out fine.
So hopefully those of you who have watched previous jump starts, I'm thinking, why are you here again? But I'm glad you are. If you are, this demo will be somewhat familiar to you. This is an old favourite. The Captain's Log. Anybody remember the Captain's Log?
I thought it was going to be cheese.
No, but this is a Rob Mars production.
It is.
The Captain's Log.
Captain's
But
Log.
I have actually I've changed it slightly. So there is two variants of this. So let's check. I've got my breakpoints in. I've lost the plot here because we're kind of making this up as we go along. Right, so I've got a file. All my storage code is in here. Right, I've got breakpoint, yes.
Excellent.
So actually there's two variants in here, the old style isolated storage and the new style Windows.storage. So let's just run that on the emulator. We've got some breakpoints I could just step through. But the reason why this is interesting, because actually it reveals, when I was building this demo, it manifested an unexpected result. And it's something you can learn quite a lot from.
So this is Captain's Log Supplemental.
Supplemental.
Nice.
Yes, absolutely it is.
I'm not wearing a red shirt.
Promise not to beam you down.
Okay, so the emulator is booting. Unfortunately, I shut it.
Yes. Did you go back to English?
I just closed it.
Francais?
I forgot, and then booting it just takes a little while.
Yeah,
so
it does.
Please admire this lovely loading ... You can see
Yes.
here. While it's loading, actually, what I'll do is show you some of the code. So here we go. This is a storage file. See if a file exists. Open it and this kind of stuff. Read the contents of the file, and we're going to call this when we launch the app to read stuff out of the storage, and then when we close the app, we're going to save it away in the storage.
Excellent.
But this application has got an interesting characteristic. So
there's a plot twist here.
There is a plot twist here, yeah. So you have to pay attention.
Excellent.
Yeah. So
so get closer to your computer screens as you're watching this.
So mainpage.xaml. So mainpage.xaml. Here we go. Log entries. It has on it just a text block which shows the entries we read out of the file. There we go. Text block in a scroll viewer. It's called the complete log text block. And if we go and view the code behind, you'll see that. There we go. On navigated to. Oh, we've just started the app just to Let's confuse matters. All right, the app is running. Here's our emulator. We're in the application startup logic here, so we're going to go through and open the file. Does the file exist? It's the first time we've ever run this. But we've caught it. We caught it. Yeah, it's a shame there isn't a does file exist method.
Sorry, kindergartners out there.
But if the file doesn't exist, then we just initialize the data to nothing, and we just let it run. There is nothing in the emulator, which is here. There we go, nothing at all. We could add entries onto here, and then we can go and we can put an entry into this. And cheese. There we go. Got to have some cheese in there.
Yes.
And then we can save it, and there we go. And then we can close the app, and we can reload it. And of course, this time we'll avoid that pesky file does not exist thing, because we're going to load in, and this time we're going to try and open the file, and yeah, it does exist. So so there we go. So then we just read the stuff out of it. And I'm just going to let that run now because it's kind of boring.
So it seems like our captain's panicking a little bit because of the asteroids.
But what's going on? Where's our asteroids and our cheese gone?
I don't know. You know, Han Solo would not have been afraid of the asteroids, and he probably wouldn't have had the problem that you're facing now. What's going on here?
What's going on? Let me explain. Okay, so yeah, first time I wrote this up, I ran this, and what should be in there, because you saw the code, I stepped through it, it read the stuff out, and it should have put it onto the screen. So actually what's going on? Let's have a look. And it's quite instructive. So you'll see that this method here that I just stepped through reads the data contents of that file, and it returns. This is one of these weirdo and async task string things. Actually returns a string which is the contents of the string, the contents of the file. And if we see, where is that reference from? Final references. That is called from. Oh my god. app.xaml.cs. So it's called, and we store this .log data is where we store the string we get back from that. And then I was just in the middle of telling you when it started up and sort of spoiled the plot that on navigated to in main page.xaml we get a reference to the app class, and then we actually go and pull that value out of there, that log data static variable, and stick it onto the screen.
Right.
So it should have been on the screen. So why wasn't it on the screen?
I think you're assuming again.
Well, this is what is interesting, because if we look back at where that was called, this is in the application activated. We're going to talk after lunch about the application lifecycle. The application activated event handler is what executes when the app is starting up for the first time. And you'll see that there in here we call this awaitable method, load contents out of the file, and we stick it into log data. But here's the deal. So this is the thing with awaitables. It's kind of, in this usage anyway, it's a fire and forget. So it's going to go off and load the stuff out of the file, and at some point later it's going to come in and stick it into that log data variable.
So it's not really.
But because we didn't wait for it to finish, because we didn't wait for, because what it actually is this method was not awaited.
Right.
So the caller, which is the runtime, it sort of said, okay, execute application activated for me. It went off. We got as far as this. And the await thing, it said, oh, okay, you go off and do that in the background, and please, when you call me back when you've got a result. But in the meantime, this carried on. So we went down here and down here.
Right.
It went on, and it dropped out of the bottom. Our main page loaded while we were still off in the background loading the stuff out of the file. And by the time we got to the on-navigated to, this hadn't been loaded yet, which is why we're seeing nothing on the screen. The answer is quite simple, which is to not write rubbish code, is basically the answer.
I knew it was going to be something clever.
This is an example of rubbish code, what I just showed you there. It's a badly structured application. And the answer is, instead of using static variables for your data in the app.xaml.cs, instead of doing that, we instead have a, where's it gone? We actually use a view model to store the data in, rather than having as a static property of the app.xaml class. So I've got a view model in here instead, which is now, this is where our repository for the data is. So when we go off and read the file, we set this property in here, which does our iNotify property change stuff. Remember that?
Yes, I do.
Fires the notify property changed, and on our main page.xaml, that now data binds against the that view model. Here we go. It's binding about that. So it's binding now against our log view model object. So it means that the code to read the stuff out of the file can take as long as it likes,
right.
but when it eventually calls back, it's going to get the data, stick it into this view model, the iNotify property changed event will fire. The main page is still already displayed, but then the data will sort of load in after the event.
Magically appear when it's time.
Appear.
So you don't have to write any special code.
Another good reason for using view models and data binding.
I'm sold. All right.
Okay.
Well, let's move along. Next up, we need to talk about special folders. You know the ones I'm talking about. All right. So we talked about we have this local folder, formerly known as isolated storage, or could still be known, depending on your take on things. It's a read-write place. And you can put files in folders and whatever you want, but there's also going to be some extra folders that are going to be reserved by the system for certain things, certain tasks. So there's this shared media files, subfolder, which is a good place for album art.
Yeah. So this is where you're using the if you've got an app that's playing background audio.
Right.
So you see the normal volume control appears on the top of the lock screen, that sort of thing, and you can select to have the album art shown on the lock screen if you're playing any audio. So if you are controlling what audio is being played by your code, then you can have album art in there. So that's one usage of that.
Gotcha. Universal volume control. That sounds like a giant dial volume control that controls every stereo system in the universe. Quadraphonic sound.
If that's where you want it to be, that's what it will be.
And it can go up to 11.
Oh yeah, we need that.
Right?
We need that.
Yes. Spinal Tap, absolument. So we also have some shared shell content. So that's images for tiles and things like that, right?
Yeah. So if you've got code that's updating tiles, that's where the images need to be.
That's the place to be. And then last but not least, for that fun little background file transfer, there's a place for those files to live too. In those shared transfers. So that's where those guys are going to be. So keep that in mind. So next, we've done simple file saving and loading. Now let's do something, let's talk about a different topic, which is kind of like what we're doing. We just didn't come out and say it. Let's talk about data serialization. There's the life cycle of this application. And you need to, the big takeaway here is at different times, you need to save serialized data that the app needs, and you need to reload it, deserialize it, and rehydrate it and use it in your app. So that's the big takeaway as we go through different phases of the model. So why in the world would you want to do that? You might have collections of objects in memory that you're accessing, and as you move through the life cycle of your application, you might need to save that data, and then pull it out again. And it's so we've gone beyond simple files, collections of objects. It's really kind of like a table, a database table if you think about it. A collection of objects, the objects being the rows and the properties being the columns, and it's in memory. And we have this great thing called link that lets you query them just like you would a database. And then at any given time, you might want to flush that data to locals to the storage area. And so we make it easy for you to do that because that's a critical use case in any application when you start having more complex data. And so we give you these serializers. One's an XML serializer. Obviously, it saves it as XML. The data contract serializer, which is also saving as XML.
Yep.
And then, of course, the JSON version of the data contract serializer, so it's a little smaller format. It's a JSON. And then, of course, third-party ones. What are the, there's a bunch of good.
There's a bunch of ones, yeah.
All right.
JSON.net.
JSON.net's a good one. Yeah, very fast. Very fast. So here's an example of using data contract serializer. You want to save a collection of objects you have in memory. You probably downloaded that collection. You called a web service that queried SQL Server or Azure database to pull that data down, or table storage or something. And you want to save that. You want to work with that, and you need to save it down to your local storage file. And so here we're going to pass in whatever that data type that represents that collection of data and objects in memory. and we're going to save those objects. And so we start off with a storage file with the await, like we talked about before, and then we create we open the stream to write for this thing, and then we use the data contract serializer, and we pass in the data type and get what type it is, because it needs to know that to properly serialize it to write this to the proper format, and then we just write out the object, and it's really that simple. And you can kind of see an example at the bottom. Kind of looks like a generic list and how you might pass that in. And again, all this code is available and these slides are available, so that if you find yourself needing that kind of in-memory NoSQL kind of thing to complement things you may be doing with SQL CE or SQLite, this is definitely a great option for you. And then, of course, the reverse looks almost the same. We're passing the things. This time, though, of course, we're going to pass in. We know that we're going to pass in the type, but we also pass in the file name. And so we need to check to see the file's there. We open it up. We have the type of, just like you saw before, and then this time we read that object and we cast it as the data type, and then you have that collection back in memory again for you to work with for your application. So pretty simple stuff. And again, it's not simple if you didn't know the boilerplate code to do it, but now you have it, and you can definitely use it for your own applications. So there's a neat tool that's been around for a while called the Isolated Storage Explorer.
Yeah, came with a 7.1 SDK.
Yeah, so this is something you use in case you want to take a peek in at what's actually happening.
You can go and go and grab all the files that has been saved into your local folder.
Yep.
And copy them up to your PC, have a good look around. You can copy stuff down again as well. So
it's a kind of a sanity check, kind of a make sure
good for diagnostics. So
make sure it's really doing what you think it's
doing.
Right,
yeah.
And of course, you have the command line.
Yeah.
And we know how much people love command line tools.
Oh, totally.
Right?
Yeah.
You probably can't get a job in this town if you're not a command line guy.
Although, if you aren't a command line kind of person, there are. If you go and look on Codeplex, there are a couple of packages that have been created that give you nice GUIs for this kind of thing.
Excellent. All right. So GUIs for GUI people. All right. So last but not least, I think, we have those SD cards we talked about. They're back. We used to have them, and we didn't have them, and now we have them again. So external SD cards. Those are primarily for media, videos, music, things like that. And so we support them, and you can discover the files that are on there. You can, enumerate. First, you can detect and see if you have a card or not, and then you can take a look at it. The one thing you cannot do is you cannot write to the SD card, so it's a read-only thing. There's a little security involved in this. And of course, like a lot of things we'll probably talk about over the next day or so, is declaring certain capabilities in your manifest file in order to do that. And so in this case, there's the removable storage capability that you've got to have in there. And so you declare that here, and it looks like you're gonna have to use an editor to do this. This is not going to be in the manifest, the UI tool inside Visual Studio. So you're going to have to put this file type association element in by hand. But, I know you can do this. This is not hard stuff. And drop it in, and you'll be creating, ultimately, the key part of this is the file type, the content type, and what the extension is. And so basically, it's kind of making that connection, that one-to-one connection. The app itself and the potential files that you're going to get, they know about each other. You're not building something that's a free-for-all that can just do a wildcard and get any kind of file you want. So here's a list of some of the external storage APIs. Obviously, the one for the device, just representing an SD card itself. Again, you need to detect. Not all the phones are going to have an SD card. Some of them do and some won't. That's up to OEMs. And then you'll look at storage folders, look at the files themselves, and then be able to get them and open them based on the ones that you've registered in your application. Of course, nothing would be complete without some best practices, right? Because you're more likely to use worse practices if we don't tell you otherwise, right? Unless you're bright, which maybe you probably are. All right, so when we're talking about files, you're probably thinking, wow, how far can I go with this? Could I put a 20 gig file on my device?
Yes, you can.
Yes, you can. Is that a good idea for all the music that's already stored or all the other apps that are needing storage space?
No, it's not.
No, it's not. We want you to be a good citizen with the other, and recognize there's other apps, maybe lots of apps that a user has downloaded to their phone. Those apps all have their storage area and they're using it. And so you need to be considerate. And I think that's a common theme in a lot of ways about building apps is be thoughtful of the end user and their scenarios. And so don't use all that space. And when you are using space, clean up after yourself if it's temporary data or if it doesn't really need to be there. If it's not relevant in the moment that a user needs to have it, store that stuff in the cloud where appropriate. And then serialization and threads. Why in the world would we need to worry about threads when we're serializing?
Well, actually, that example we showed with the async await,
Yeah.
where we're loading stuff, actually what that does under the covers is spins off that operation onto a background thread. So you're kind of inadvertently using threading
so
when
you
you
get it
use
for
those
free?
APIs. You get it for free.
I like
But
that.
if you've got your own custom code that's doing
Yeah.
that sort of thing, you probably want to. You don't want to be tying up your main UI thread with doing that kind of stuff.
Absolutely.
It's slow stuff.
Because if you
comparatively
have a really large collection of objects,
yeah.
Thousands, however many rows, basically, obviously that's going to take longer to save, to serialize. And so, so having that background thread to do it so it's not freezing the UIs is critical. Alrighty then. Well, we have successfully made it through files
Woohoo. There we
and
go.
folders and serialization.
Yeah.
I hope you loved it as much as we did. You know what I think it's time for, don't you?
Food.
Food.
For us.
Yes.
And
I don't know what...
If you're over in Europe, I guess it's kind of, almost Horlicks time.
It's time for tapas or something like that if you're in
Later
Barcelona, right?
Yeah, that's right.
Okay, that's where my head's at.
I'm with you.
Excellent, excellent. Rioja. Anyway.
Yeah. So we will be back at the top of the hour, which is in around, 35 minutes' time.
Wow, that's pretty fast.
Oh, that's a pretty swift lunch.
Yes, we're going to do a swift lunch.
Yeah, we're going to try and claw back a little bit of time.
Yes.
But I hope you'll see us there. Thanks
All right.
very much.